Greetings, this is Daniel Rose, publicist for Group 1, and I will be walking you through our team regression report. We'll begin by describing our data. The model we are working with includes 4 variables, 3 independent. Our first independent variable is binary, while our other 2, as well as our dependent variable, are continuous. Our descriptive statistics table sheds additional light on the nature of the variables we're working with. Again, our first independent variable is binary, while our third, in the right-hand column, seems to be normally distributed, with a kurtosis value close to 3, skewness value close to 0, and mean and median values very close to each other. Our other 2 continuous variables, however, both have very high skewness and kurtosis values, and mean and median values that are far apart from each other, all of which suggests that these variables are less than normal. We can see this analysis play out in our histograms. In the top left and right-hand corners, we can see that both of these continuous variables exhibit large ranges, with maximum values that do not appear on the histograms. Instead, the large majority of the values are clustered on the left-hand sides. In the bottom right-hand corner, we can see that our third independent variable appears to be less than normal. However, given our descriptive statistics, we might conclude that it is in fact normal, or close to it. Now, having described our data, we will move on to the empirical results of our regression model itself. Here in the regression table, we can see all of our relevant values. Firstly, our constant term in the bottom left-hand corner is very small, but it has a very large p-value, so it is not significant at any level. However, all 3 of our independent variables are significant, beyond 1%. In the top right-hand corner, we can see that our r-squared value, which is very low, suggesting that our model explains only about 5.7% of the variance within our dependent variable. Given the very large residual value on the left-hand side, we can conclude that many other variables that this model does not cover are providing explanatory power and cover the remaining 94% of the variance in our dependent variable. We can provide additional interpretations for these coefficients. Again, our constant value is very small and is not significant. Beta 2 and beta 4 are both very large. However, beta 3 is small. Beta 3, our second independent variable, does not contribute much to our model, but all 3 of these variables, all 3 of these coefficients, are significant at better than 1%. And so to recap, the implications of our model include that while our coefficients are strongly significant, our model only explains a small fraction of the variance in our dependent variable. All of this suggests that our model, while reliable, may or may not be useful. Finally, I would like to thank everybody in Group 3. Everybody contributed to this project and our report. And this is your publicist signing off.